113. I just wanted to do a quick video to recap what we did in Zoom today if you missed it. Couple things. First of all, I will be holding office hours on Zoom tomorrow from 11 to 12 and Friday from 10 to 11. I will send out an email later today with the link to that. It will be a different Zoom link than your class one. I will also tomorrow put up homework that's due Sunday. It won't be too long, 4 or 5 questions. And then a video with the new material. If you remember, we're having our Zoom class twice a week, but we still need to have 3 days of material, just like we would in class, so there'll be some new material up on Blackboard tomorrow. Also, please remember that your fraction activity reflection is due by Sunday. Okay, so in class today, we spent really most of the time talking about the questions that I had left you with yesterday. So we were talking about subtracting. The two we had left with were 42 minus 39 and 104 minus 87. And looking at the standard subtraction algorithm and what really is happening behind the scenes when we borrow especially. So in class today we broke into groups, people talked through what they had done. And then we shared with the class what we had come up with. So we're using the same, rods, flats, units idea here. So if we want to write 42, it would be 4 of the rods and 2 of the units of the little blocks. Now, when we are adding, we wrote both numbers in that format. You can do that if you want here, but sometimes it gets a little tricky because you sort of visually want to add them. So sometimes what I've seen done is to write the second number in our regular numbers so we can think about what we have to take away. So let's look at the ones place, right? We have 2 units here. We want to take 9 away. Clearly we don't have enough. So what we can do, just thinking about our blocks for a minute, is when we have one of the rods, we can break it up into these 10 pieces. Okay, this is actually just one piece, but if I had made it out of these little blocks, the little units, then we could actually physically break it up, right? That might be a nice way to show your students too, to have them actually be able to break it up. So if I break up this rod, that means I don't have one of those rods anymore, but it comes over here and gets broken up into 10 units. So now I have 12 units here. That is enough to take away 9. So I can cross out 9 of them. And then what I have left would be 3 units. Okay. Now over here, I started out with 4 rods. I don't have one of this one anymore because I broke it up. Okay, it's like if you have 4 $10 bills and you change one into ones. You still have the same amount of money, but you don't have 4 $10 bills anymore. You have 3 $10 bills and 10 ones. Same idea here. So now we have 3. We want to take away 3. I take away all 3 of those. There's nothing left in the 10 spot. Okay. So if we think about the standard subtraction algorithm, how we normally subtract and what's really happening then. So again, you know that I'm a big proponent of not just saying cross this out, put this here, right? We want to talk about why. So you're going to try to really get across to your students that we're not just blindly crossing this out and adding a 1 here. We don't have enough ones, but we can take one of these, one of those rods, so I have 3 left. The reason we put a 1 here is because every time we break up anything from any place value, it becomes 10 of the next place value, right? We've talked about that a lot, these bundles of 10. So the reason I put 1 is because if I have a 0 here, right, it's like 0, 2, what I'm going to have, I add 10 to it, now it's 12. And then I can go ahead and subtract. If we came over here to 104, so this is going to be one of the flats, no rods, 4 units, and I want to take away 87. Again, I don't have enough over here in the ones, so I need more ones. Well, I look at the 10s, and I don't have any 10s here. So I have to go all the way back over to the flat, to the 100s. And if I cross out this flat, it is going to give me 10 rods, right? 10 tens. 100 gives me 10 tens. And then now I can go ahead and cross out one of these and it becomes my extra 10. So now I have more than enough to take away 7. So if I cross out 7, I have 7 left. Here I had 10 after I moved these over, but I used 1, so I have 9 now. I'm going to cross off 8 of them. So I just have 1 left. I had 1 flat. I broke it to get my 10s, so I do not have any more left. Okay. Again, let's think about what happens when we do traditional subtraction algorithm. Okay, 4 minus 7. Now, it's really common for students to want to flip it and say, well, I can just do 7 minus 4 instead. Can't do that, right? Here's what we're starting with. We have to take away the bottom number. So we don't have enough. So we look next door. We can't turn this into anything, right? Sometimes it's they just want to, students want to just cancel that out and make it some number. We can't. There's nothing there to take from. It's an empty spot. So we have to go all the way over here. This is going to become 0 because I'm taking the only one that's there, and this becomes 10. Now, I have 10 of these. Now I can borrow one of these. I can split one of these up or unbundle it to give me more ones. So that becomes a 9. 4 plus 10 is going to be 14. Okay. Sometimes there's a tendency, especially if we have to borrow a few places in a row. So let's say I have this. So I can't do 5 minus 8. I go next door, there's nothing to borrow. I go next door, there's nothing to borrow. I have to go all the way over to the thousands. And this becomes a 10. Okay, now sometimes there's this tendency for students to want to say, okay, this is a 10, this is a 9, this is an 8. Not how it works, right? Every time we bump over, it's going to be a power of 10. So I have 10 hundredths. That's going to become a 9. 0 plus 10 gives me 10, right? I took away one of these flats and it gave me 10 rods. Now I'm going to take away one of those rods. It's going to give me 10 ones. 5 that I had plus the new 10 is going to be 15. And then I can go ahead and subtract. Okay. Also kind of shows why we always want to start with the ones. If we started here, let's say, we could do 4 minus 3, we'd have a 1 here, but really we can't keep that 1 here because now we have to give it back up here to unbundle. So we always want to start with the ones and work our way larger. So we spent quite a bit of time talking about that today. And then the other thing we did was to look a little bit at the same idea of borrowing and carrying. We really just did a carrying one, but when we're not talking about regular old numbers. So the example we had said that Rosie ran around the lake twice. And the first time it took her 1 hour, 43 minutes, and 38 seconds. And the second time it took her 1 hour, 48 minutes, and 29 seconds. And we want to know how much time she took all together. Okay, so we're going to add these two together. So again, go ahead and stop the video for just a minute. Add those together and think about the idea of carrying when you do that and bundling. Okay, so hopefully you paused the video, you're back now with an answer. So if we go ahead and we add each of these, if I add 38 and 29, I'm going to get 67 seconds. And if I add 43 and 48, I'm going to get 91 minutes. And if I add an hour and an hour, I get 2 hours. So she ran for 2 hours, 91 minutes, and 67 seconds, which technically is not wrong. Okay, that is how long she ran for. But hopefully you see something that's a little weird, right? We don't usually say, well, put that in the oven for 2 hours and 91 minutes, or that's how long the movie is, or that's how long I was at the park. Okay? Same thing with 67 seconds. Each of these, instead of getting bundled by 10, like in just our regular number system, seconds are going to get bundled by 60 because there are 60 seconds in a minute. So once we get to 60 seconds, we need to bundle that and make it a minute. So one way to think about this, or to maybe write it out for yourself, is to think of 67 seconds as a 60 plus 7. So this 60 here, that 60 seconds now becomes 1 more minute. So now I have 92 minutes. Well, 92 minutes is also more than a bundle of what I need because 60 minutes is 1 hour. So I'm going to think of 92 as an hour, 60, plus 32 more. This 60 minutes comes over here and gives us an extra hour. Okay, so I took this 60 minutes and made an hour. I took the 60 seconds and made a minute. So I end up with 3 hours, 92 minutes. Oops, sorry. Take that back. 3 hours, 32 minutes, right? Because I took my 60 away. And 7 seconds. So we can bundle by different things. We're used to base 10. Essentially, this is base 60, meaning that every time we get to a group of 60, that's when it bumps over to the next unit. Okay. Obviously, if we're talking about hours, 60 hours is not really a special thing, but 24 hours would be. If she ran for 27 hours, we'd probably say 1 day, 3 hours. Okay, so you got to think about what you're bundling by. So that's what we did in class today. The new material that I will put up tomorrow will be dealing with adding fractions and adding mixed numbers. And how adding mixed numbers really ties into this also. We need to look at adding fractions first. Okay, so again, watch for homework. That will be up tomorrow. And the new video will also be up tomorrow. Your homework is due Sunday. If you want to pop into office hours, it's those 2 times the next 2 mornings. And make sure that you are also working on your reflection for your fraction activity. All right, I will talk to you guys soon.